Hello everyone, today I'll be talking about how to name alkanes and cycloalkanes. First, alkanes is a saturated carbon, contains saturated carbon atoms. This is for the straight chain that doesn't contain any side groups. If this group doesn't exist, we will name them according to numbering the carbon atoms as a suffix. Then we will use the prefix ane. So like in here I have 8 carbon atoms, so I will name it octa. Then I will use the prefix the suffix ane. Because I have here a branch, I will try to number my branching with the least carbon with the least numbering. So if I number from this side, you could see that it will be at the position number 4, but if I number from this side, it will have the position number 5. This is why I have to number from this position. So I would number from 1, 2, 3, 4. So the branch is at the fourth carbon, and this is why I will write the branching, which is 4-methyl octane. Now, the prefixes that we use in here, there is a table for some of those prefixes from 1 to 20. When I have 1 carbon atom, I will use the prefix metha, and if I have 2, it's etha, until you have here hexa for 6 carbon atoms, and octa for 8 carbon atoms, nona for 9 carbon atoms, and we have also up till the 20 carbon atoms. Now, there is a line structure like in here, and this is the structure formula. If you are comfortable with naming your structure in this one, you can name it in this one. If you are comfortable with this structure, you can name on that one instead. So if I look at this structure in here and I try to number, so in both ways, my side chain is at the middle carbon atom, which at the position number 2. It doesn't matter if I number from this side or that side. So at position number 2, I have methyl group. So I have 2-methyl propan. Now, if I look at this structure, and in here I have the methyl group at the position either number 2 if I number from this side, or it can be at the position number 4 from that side. This is why I should number from this side. I don't say 4-methyl pentane, but I say 2-methyl pentane. And pentane, because I have 5 carbon atoms, so I take from the table here carbon atoms penta, so it is pentane with the suffix ane. So when I try to name according to IUPAC, if I have 2 side chains from the same type, I will try to number them to give them the least numbering. So if you could see from here, I will give my 2-methyl groups in here the least numbering if I started from this side. But if I started from that side, they will have like the position number 3 and 6, which is higher. This is why I will number from this side. And because I have 2 groups, I have to indicate that I have 2 side chains. First, I would write the position of, according to IUPAC, you need to write down the position of your side chains. So I have at the position number 2 and the position number 4, and I will indicate that I have 2 groups by writing dia for 2. If I have 3 side chains, I would write tria, tetra, if I have 4, and so on. So dimethyl, because I have here 1 carbon atom, so I would name it methyl. Then I will count as my parent chain, which have 6 carbon atoms, so I have hexa, and I will use the suffix ane to indicate that I have 6 carbon atoms. In here I have 2 side chains, and they are not similar groups, but in here I have methyl, and here I have ethyl because I have 2 carbon atoms. So which one and which numbering I should take, because in here you could see that it will be at the position number 3, and from this side my methyl would be also at the position number 3 if I number from this side. But according to IUPAC, we should consider the alphabetic order. So because E comes before the M, I would number from that side, not this side. So I would number from this side to give my ethyl first the least numbering. So I have 3 ethyl. Then I would write the position of the methyl group at the position number 5. Then I will write down the name of the side chain, methyl. Then I would name my parent chain, and in that case I have 7 carbon atoms. This is why I have hepta. and I would use the suffix ane to indicate that it is a saturated alkane. Now, according to IUPAC, when I name something like these two compounds in here, you could see that I have here a branching, and I have here two at the same carbon atom. I have here two at the same carbon atom, and here I have ethyl group. Now, according to alphabetic order, I should have started from that one, but you have to remember one thing. I'm giving my side chains the least numbering. This is why I should number from this side. So I would number 1, 2, 3, 4, 5, 6, and this is 6 carbon atoms. So I would name it on that side because I will start from the alphabetic order ethyl. So I would put the position of the ethyl group for ethyl. Then I would write down the position of the two methyl groups, so at position 2 and 2. Then I would write down that it is dimethyl because I have two groups. Then I would write the longer chain, which in that case I have 6 carbon atoms, so it is hexane. And you could see that I used ane at the end. Now, if I looked at this one, and you could see that there is a branch in here, and for that, where there is two or more parent chains, I would use those parent chains are identical. I would try to make my parent chain the one with the greatest number of substitution. What I mean by that, if you looked at this parent chain, I have here one parent chain with this as a side chain, the isopropyl as a side chain. But if I looked at this structure from that point of view, I have here a parent chain with the same carbon atoms. So I have here 1, 2, 3, 4, 5, 6, and here I have 1, 2, 3, 4, 5, 6. You have to remember, if the pose parent chains have the same carbon number of carbon atoms, I would use the one with more branched side chains. So here it have ethyl. If I use this one, in that case, I would have here ethyl, and I would have here methyl. But if I have the straight one, I would have isopropyl only as a side chain. So I choose this one, and I will start numbering from the side to give my methyl the least numbering in that case, and I will start from this side. So I have 1, 2, 3, 4, 5, 6. Although it is similar to have a numbering from this side, but now I have two side chains on my structure. One is methyl and one is ethyl. So I would number the ethyl first according to IUPAC, because it's here ethyl E, but here is methyl M. So I would use the ethyl first. So at the position number 3, I have ethyl group. Then at the position number 2, I have methyl group. Now moving to my parent chain is hexa, and I use the suffix ane to indicate it's a saturated alkane. Now, what about cycloalkanes? Cycloalkanes, I would take the word cyclo to write it before the name, the number of my carbon atoms. In here, I have 3 carbon atoms, so either the structure formula or the line formula. So I would write the word cyclo. Then I would write the number of my carbon atoms, which is propan. Here I have 4 carbon atoms because I have 4 corners. So I have here cyclobutane. In here I have cyclopentane for 5. And in here I have cyclohexane. If I have any side chains, like if I have here a side chain, so if I have here methyl group, I would give my side chains the least numbering. So at this position, I would number it number 1. So I would write 1 methyl cyclohexane. For bicyclolakanes, bicyclolakanes are compounds which they have fused rings, and they meet at they have this side which both of the rings are sharing. For numbering them, I would number first the largest ring, then I would number the smallest ring. So I would number from this side, and I will take it as a circle. So I have here 1, 2, 3, 4, 5, 6. Then I would write down here 7, 8, 9. So you could see that I just like drawing a numbering circled number around my structure, and you could see that there is a bridge here between both rings at the position 1 and 6. To name this type of alkanes, I write the word bicyclo to indicate that I have two fused ring, and in that case I would write down the position of the carbons, the number of carbons on both sides of my ring, with no so I'm not gonna count those. I would count them separately. So I have here 1 2 3 4. I have 4 carbon atoms in this ring, and I have here 1 2 3. I have 3 free carbon atoms in that ring. Then the fused position, I have 0 sharing of these carbons. So here I would consider it to be 0. In that case, I would name my structure bicyclo 430, and the longest chain means nonan. So I have here 9 carbon atoms. Let's look at that structure, this structure. So I have here, if I number, I can number from any side. So I have here 2 hexa rings, and in that case I would number them as my parent chain would be 10 carbon atoms, but I would write the word bicyclo. Then I would write the position, the number of carbons on both sides. I have here 4 carbon atoms. I have 4, and here I have also another 4. And here at the meeting point or the bridge point, I have 0 carbon, 0 pointing in that case in this bridge. And I would write my parent chain decan. You would understand why I consider this one to be 0. If you look at this one, in here they have 1, 2, 3 points. So this point is a middle point. So I don't number the side which is shared between the fused rings, but I name that point which is separated from those two structures. So in here I could number my structure in that case from this side. I have here 1, 2, 3, then 4, 5, 6, and would give this point 7. And when I name my structure, I would name it as well bicyclo. Then I would write down the number of carbons on both sides. I have 2 and 2, and I have here 1. So now it is this separated. So I don't read the fused rings position, but I read this one because it's not fused between them. Then I would write the parent chain, which is heptane, because I have 7 carbon atoms. Now let's look at this exercise and try to name each structure. In the first one, when I try to name my structure, in that case I have this functional group, which is in that case it's a ketone group. For ketone group, we use the suffix ONE at the end of my structure. So if I looked at my structure in here, I have 1, 2, 3, 4. I have 4 carbon atoms. This is why I have buta. Then I would write the suffix ONE to indicate that I have a ketone group. In here, it's similar to this ketone, but I have here hydrogen instead of methyl. In here, I could have any other, so I could have ethyl instead of methyl. But in here, I have hydrogen. This is why we will name the CHO, is in that case would be aldehyde. And this aldehyde group, we would give it the suffix Al at the end of my naming. So I have here 1, 2, 3 carbon atoms. So I have proba. Then I would proban. Then I would proba. Then I removed the E from the ANE. Then I would replace it by Al to indicate that I have aldehyde. In this example, in here, I have carboxylic group, C double bond OH, and in that case, I would number from this side. So I have 1, 2, 3, 4, 5, 6. I have 6 carbon atoms, so I would name my structure hexa. Then I would replace the E with the OIC suffix. So the OIC indicates that I have here acid. carboxylic acid takes the suffix OIC. Here I have hydroxyl group, and if I number, I can number from any side. So I have here 1, 2, 3. So it's at the position number 2, and on that case I have 2, and I have 3 carbon atoms propan. Then I would use the suffix OL to indicate that I have hydroxyl group. In here I have a ketone structure, so this is a C double bond O, similar to that one, but I have a cyclic structure. This is why I would use, then I would write down the number of carbon atoms that I have, which is hexane. Then I would use the suffix ONE at the end of my structure to indicate that I have 6 carbon atoms. So cyclo. So I used the prefix cyclo to indicate that I have cyclic structures. Then I would use in the middle the infix hexane to indicate I have hexa structure. Then my suffix would be ONE at the end to indicate that I have a ketone. Here I have hydroxyl group with a cyclic structure. In that case, I would name my structure cyclo as well, and I have 3 carbon atoms, so I have cyclopropan. And I would use the suffix OLE. So I have the here cyclopropan to indicate my infix indicates the number of carbon atoms. Then my suffix in that case would be OL to indicate I have hydroxyl group. Now, if I look at what if I have double bond? If I have double bond, this means I have alkene, not alkane. I would show it in a separate video, but in here, just for a quick naming, in that case, I can number from the side to give my double bond the least numbering, and I would number from this side to give it, in that case, propene. So you could see that I replaced the suffix ane with ene, and I kept my prefix as it is because I have 3 carbon atoms. In here I have cyclic structure, and in that case I have double bond, so I would number to give my double bond the least numbering. And in that case I have 6 carbon atoms. So I have cyclo, because I have cyclic structure, then I have hexane, hexa, then I have ene to indicate that I have, in that case, a double bond on my structure. Now moving back to alkanes, let's try to name those alkanes and cycloalkanes. And then here I have to number my structure, I have this side chain, and I can number my structure from this side to give my side chain the least numbering. So I have here 1, 2, 3, 4, 5. I have 5 carbon atoms, so I have first I have to indicate the position of my side chain. 2, methyl. Then I would name my structure, in that case pentane. I would use ane to indicate that I have saturated alkane. In here you could see that if I started from this side, I will give my position, my methyl side chain position number 2, similar to that if I start from this side. So it is similar, so I can just number from 1, 2, 3, 4 from this side, 5, 6, and in that case I have 2 methyl groups, and I have to indicate the position of these 2 methyl. So I have at the position number 2 and 5 dimethyl. Then my parent chain is hexane, and I would use the ane to indicate that I have hexane. In here I can have 1, 2, 3, 4, 5 this structure as my parent chain. But if I looked at this one, I have 1, 2, 3, 4, 5, 6, 7, 8. I have this one as a parent chain. Because this one is longer, I would consider this one to be my side chain, and I would number from this side. So if I number, I have 8 carbon atoms, and I have a methyl group at the position number 3. So at position number 3, I have ethyl. Then I would name my parent chain, which is octane, and I would use the suffix ane. Now I have this branching structure, and you could see that if I looked at this branched structure, either I can name it from this side, so I can number from this side, or from that side. But in here I have more substituent on my carbon atoms. This is why I would number from this side. So I have 1, 2, 3, 4, 5 at the position, and here I have 6. So at the position number 2 and 2, I have methyl, and 5 also I have methyl. So this is why I have trimethyl. Then my parent chain is hexane. Let's look at this structure, and it's a cyclic structure. So I have here at this position number 1, I can number my structure to have 3 carbon atoms. This is 3 carbon atoms attached to my cyclic structure with a side chain which is a methyl. So I would write the 2 methyl, and in that case I have this side chain which is propyl, and my parent chain is the cyclopentane. So by that we came to the end of the video. Until next video, thank you and goodbye.